This is the that my today I am going to start topic function. Today I am going to start the topic function. This is for class uh, 12 student, for class 12 student. What I want to first of all I want to tell you, most of the students are not clear with functions. So what is the basic of this function? You have already learned in class 9 and 10. You have drawn the graph, such as you have drawn the graph y is equal to 3x plus 4. You have drawn this graph. These are linear graphs. So you, in class 10, you made a box like this. You made a box like this, x and this x and y. You place the value of x is equal to 0. You got 4. When you placed minus 1, you get this is 1. When you place 1, you get 7, and so on. Now when you draw this graph, this is your when you draw this graph, this is your x o x dash and y o y dash. And when you draw this, for 0 it is 4, say somewhere like here. I'm taking somewhere. For minus 1 it is 1, somewhere like this here. And for 1 it is 7, somewhere like this here. So when you draw this graph, you get a straight line. When you draw this graph, this is a straight line. You get a straight line. You get a straight line. You get a straight line. And this is the graph of y is equal to 3x plus 4. This is the graph of y. You have already drawn such type of graph. So this is what? This is a function. After all, this is a function. Your x, for a given value of x, you are getting a given value of y. For a given value of x, so for given value of 0, your x, you are getting y value is 4. And for minus 1, you are getting 1. And for 1, you are getting 7. So for a given value of x, you are getting a given value of y. So this is the function which you have already learnt in class 9 and 10. Here only some modification is done. That is, you can treat this x-axis as domain. You can treat this x-axis as domain and your y-axis as a codomain. Your y-axis as codomain. And now if you modify it, modify it and write it becomes f. This is a function from domain. That is, your, let this be, you can say this x, your x-axis your domain, and your y-axis your codomain, and y is equal to 3x plus 4. This is the modification which has been done in class 12. That is everything you have learned in class 9 and 10 only, but to express this, you expressed in graph, and this has been expressed as functions in this year. So here this, and the coordinates which you got, this is 0 4, and here you got 1 7, and this is minus 1 and 1. These are the coordinates. These are the coordinates which you got. So here, if you these are the coordinates which you got. So if you write like this, if you say write in set the first elements, that is minus 1 0 1, this becomes, this we call the domain of the function. This we call the domain of the function. This we call the domain of the function. And the second element, that is 1 4 and 7, this you call the codomain of the function. This is called the codomain of the function. Codomain of the function. So this is what all about functions. Not this is, sorry, this is not codomain. We call this the range of the function. This is what this is all about. What you have functions, which you have all about functions. So in class 12, This has been function, it has been written like this: f such that a to b and y is equal to fx. This y is equal to fx. That means um, this is about the function. So now there are two types of function. One is the one function and other is the two types. There are types of functions. There are type of functions. Type of functions. There are two type of function. One is the one function. One function. One is the one function, and second, this is the onto function. Onto function. Onto function. Now, what is your one function? One function. That means from the word it is already it is clear to you. You have drawn such type of graphs in your class 9 and 10. That means let me take a graph that is y is equal to, let me take again the same graph, 3x plus 4. So when you that is you have x and y, you take the value of x is equal to 0, we got 4. I take minus 1 1, I got 7. Similarly, if you take 2, that will be 10, and if you take minus 2, this will be minus 2. This is minus 6. 6 minus 6 plus 4 minus 2. So for each value of x you are getting a unique value of y. For each value of for different value of x you are getting a unique value of y. So this is a one function. We can say that this is a one function. This is a one function. One function. Now this definition it is given in your textbook. Definition it is given in your textbook. The definition that is given for one function, that is if f such that x to y is defined to be one function or injective if the images of distinct element of x under f are distinctive. That is the main sentence is if the images if the images if the images of if the images of uh, uh, images images of it is written like this. Let me write the definition first of all to make it clear for you. That is that is f, it is definition, it is f such that x to y is defined to be one or injective if the images of distinct element of x under f are distinctive. That is it is given that it is written that f such that this is one function, one function, this is one function, and one function, and it is given that one function x to y, and it is said that if images uh, of images of distinct element, images of distinct uh, elements distinct elements of x under f are distinct distinct under f are distinct. That means when you draw the graph 3 is equal to 3x plus 4, you got what you got, that is for x and y. For 0 you got 4, for minus 1 you got 1, for 1 you got 7, for 2 you got 10, and for minus 2, you got minus 2. So from here you find that it will go on so on from, but we find that for distinct value of x, this is distinct value of x, this is x-axis, distinct value of x, yeah, under the function f, this is your function f, we are getting a distinct value of y. So this is a 1 1 function. This is all about 1 1 function. And to write this, how you are going to state mathematically that this is a 1 1 function. To state it, we write it like this: for every x1 comma x2 belongs to f belongs to this belongs to your domain x, f x1 is equal to f x2 implies that x1 is equal to x2. Then we say that f is a 1 1 function, and if it is not a 1 1 function, it becomes a many one function. So this is how we represent this is how we represent a 1 1 function. And if it is not a 1 1 function, it becomes a many one function. So that means if you draw pictorially, if I draw it pictorially, this is your domain, this is your domain, and this is your, say, codomain. If you draw pictorially, a b c, 1 2 3, for a this is 1, for b this is 2, for c this is 3, then this is a 1 1 function. This is a 1 1 function. Now if it is like this is your domain, say this is your domain, and this is your codomain, this is your codomain, this is your codomain. Now a b c, 1 2 3, that means for a it is 1, and for b it is also 1, and for c it is 2. Then we say that this is a many one function, many one function, many one function. This is your many one function. That means I can let me make it more easier to understand your 1 1 function, make it more easier for you to make understand many one function. So let your domain, this let domain, this will be this domain, and this is your codomain, this is your codomain, this is your codomain. So let this be Mahatma Gandhi, that this be Mahatma Gandhi, who started non-cooperation movement, then it is Mahatma Gandhi. Who started Satyagraha, 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 then this is also Mahatma Gandhi. Uh, uh, um, uh, who started Satyagraha movement in Africa, then that is also Mahatma Gandhi. So this becomes a many one function. This becomes a many one function. I am trying my level best to make it simpler and easier for the student to understand what is function, what is many one function, what is one one function. So this is all about one one function. And the another function, it is the onto function, onto function, onto function. And this onto function, it is according to this onto function, it is defined in your book, that is in your textbook, it is defined that for onto function, that is f such that x to y, it is defined in your onto function. For every y, for every y that is belongs to your domain, there exists an element, there exist an element, there exists an element x in x such that such that fx is equal to y. For every y belongs to y, there exists an element x in x such that fy fx is equal to y. From this statement, it is clear that your uh, for your this is your codomain, this is your codomain, this is your codomain, and this is your domain, this is your domain. From this, it is clear. It is from this that for every y there exists an element x in for every y there x in capital X such that fx is equal to y. That means you can say like this: for every element of y there exists a pre-image in X under the function f. You can say like this, that is you can say like this, that is for every element of codomain, for every element of y, this is your y and this is your x. For every element of y for every element of y there exists a pre-image. For every element of y there exists a pre-image in X, there exists a pre-image in X under the function f, under the function f. That means you can say that you can say this you can conclude that like this, that your every element of y is booked, there is no free element in y. Your every element of codomain is booked with your domain y. There is no free element in codomain. Then you can say that this is an onto function. So I think so it is clear to you what is onto function. Let me make it more simpler. That is simpler. That is your this is your domain. Domain. This is your, say this is your x, and this is your codomain. Codomain. Say this is your y. So here you see that A, B, C, your 1, 2, 3. So you can say that your 1 is related to A, means A is the pre-image of 1 under the function f, under the function f. 1 is the A is your pre-image of 1. Similarly, B is your pre-image of 2, and similarly 3 is the pre-image of C is the pre-image of 3. So from this you can say under the function f. That means every element of your codomain is booked. No one is free. Every element is related to the domain X. When every element of your codomain is related to your X, then this is an onto function. So this is all about one function and onto function.